CPU. Look at these chips for a second. Almost automatically, your brain ranks them. Worst to best, cheap to expensive. That instinct is exactly why chips confuse people. These 8 aren't faster and slower versions of one thing. They're different answers to one question. What is this chip for? One handles anything you give it. One does a single task 1,000,000 times a second and nothing else. One can't even run a program, yet it's inside almost everything you own. So forget the ranking. Start with the one you know, the processor. That's the CPU, the generalist. Give it any task, from opening a browser to predicting the weather, and it does it. A desktop CPU has 8 to 16 cores, each running billions of steps a second. Not the fastest at any job, but it always finishes. The problem hides in that word, any. Because it can do everything, it does most things one at a time. Hand it the same calculation 1,000,000 times, and it crawls. MCU. This one is simple on purpose, and that's the point. A microcontroller is an entire tiny computer on one chip, processor, memory, and storage together. It's in your microwave, your car door, your washing machine. You've owned dozens and never once seen one. Tens of billions are made every year. The most common computer on Earth. It runs at megahertz where the CPU runs at gigahertz and lives for years on a battery the size of a coin. The downside is how little it does. No operating system, no websites, just one program, repeated forever. But that program costs a few cents and the chip never sleeps, never crashes, never complains. So what happens when you want everything a computer does shrunk to fit in your pocket? So see, that's this. A system on a chip fuses all the parts of a whole computer: processor, graphics, memory, modem, and a dedicated AI engine onto one slice of silicon. It's the chip inside every smartphone. Apple's A17 packs 19 billion transistors on a 3-nanometer process into something smaller than your fingernail. The catch, everything is fused together. You can't upgrade the memory or swap the graphics, and if one part fails, the whole chip dies. So the thing you call the processor in your phone is really a dozen chips pretending to be one. And one of those parts began life doing something unrelated, drawing triangles. GPU, graphics processing unit, was built to paint millions of pixels onto a screen all at once. Where a CPU has a handful of strong cores, a GPU has thousands of simple ones side by side. A modern NVIDIA chip has well over 10,000, which is why training one big AI model can keep thousands of them busy for weeks. Then someone noticed the maths that draws a game and the maths that trains an AI are basically the same. Millions of tiny sums at once. That single overlap made NVIDIA one of the most valuable companies on Earth. Today, entire buildings of them train the models behind the AI boom. This one wins by raw power, not cleverness. It burns energy and only does well when work splits into thousands of identical pieces. Give it one long step-by-step task, and the simple CPU wins. The CPU is a few geniuses. The GPU is an army of 10,000 interns. No single one is clever, but together they finish your homework before you've read the question. Quick question: how many separate chips are inside the device you're watching on? Guess in the comments. And if this is finally making sense, hit like, it helps. DSP. A digital signal processor takes the messy real world, sound, light, radio waves, and turns it into numbers in real time. Every phone call, every noise-canceling headphone, every Wi-Fi signal passes through one. Texas Instruments has built them since the 1980s, and they do one kind of maths, multiply, then add, faster than any general chip. You've felt it. When your earbuds erase the sound of a crying baby on a plane, that's a DSP building the exact opposite sound wave, thousands of times a second. It's a pure specialist, great at signal maths, useless at everything else. A translator who speaks one language but faster than any human alive. Every chip so far comes fixed from the factory, wired one way forever. So what if you could rewire the chip itself after buying it? FPGA, you can. A field programmable gate array is a chip with no fixed purpose. You redraw its wiring in software after it's built. Every other chip here has its wiring set made at the factory. This one is a grid of tiny logic blocks you connect however you like and reconnect tomorrow. It is literally hardware that behaves like software. Engineers use one to test a chip design before spending hundreds of millions on the real thing. The same chip runs stock trades, where a millionth of a second is money, and flies on Mars rovers. The price of that freedom, an FPGA, is slower and more expensive than a fixed chip for the same job. You pay in money and speed for the right to change your mind. But flexibility is exactly what the newest chips are throwing away, on purpose. NPU, a neural processing unit, is built for a single job, running artificial intelligence. Your phone's face unlock, live translation, instant photo edits, more and more. That's not the CPU or the graphics chip. It's a dedicated NPU measured in TOPS. Trillions of operations a second using only a fraction of the power a GPU would need. That efficiency is why your phone runs these AI tasks instantly and offline, without draining the battery or sending your private data to a server. The limit. It does only one kind of maths, the matrix multiplication behind neural networks, and nothing else. And AI moves fast, so a chip locked to today's models can be outdated in a year. It's the newest chip here, and it points to where this is heading. The better we know what we want a chip to do, the more we build one that does only that. ASIC, an application-specific integrated circuit, is designed and built to do exactly one thing and nothing else for its entire life. It has no general skills and can't be reprogrammed. Every transistor is placed for a single task. That extreme specialization makes it smaller, faster, and far more energy efficient than a flexible processor performing the same repetitive workload. This is the chip that mines Bitcoin, running that calculation thousands of times faster than any GPU. And it will never do anything else. Google's own AI chips are ASICs too. Designing one costs hundreds of millions and takes years. You build it only when you're completely sure